You see the expression a f of x minus h plus k, and what do we use this expression for? What's the meaning of this expression? Well, the context is f of x is a function. Then a f of x, well, if it's y equals f of x, then y equals a f of x. All your y values are a times is great so points are a times is far from the x-axis. So if our original function has a point here, and let's say that a was 3, okay? So if this is a point on the original function, meaning on the graph of the function, then the point on the function a f of x is going to be 3 times as far from the x-axis. We go this far, we go this far, we go this far again. Here's a point on a f of x. So I say on the function, I'll just say on f of x, on the graph of f of x, and I didn't write graph of for various reasons. Now we've been over this in much detail, so this should just be a reminder. Okay, so what about y equals f of x minus h? Well, not writing all the reasons. Shifts the graph h units horizontally. Make a note up here, this is for a equals 3. Okay, and that means that if you have a point here on the graph of a function, that if h is positive, it's going to shift that point h units. Now if h was negative, it would shift the point in the opposite direction. Then y equals f of x plus k. I was going to say y becomes, I don't like that word. Y changes by k units, so that if your point is, let's say, here, then it's going to go up or down k units. Now if k is negative, it'll go down. Well, a f of x minus h plus k does all 3 things, and it does them in a certain order. The vertical stretch has to happen before the vertical shift, okay? And this is called your vertical shift, this is called your horizontal shift, and this is your vertical stretch. So I guess we could put those words on it, although these are terms that we should be familiar with. Okay, this is a vertical stretch by factor A. This is a horizontal shift of h units. That h came out a little substandard, okay? And this is a vertical shift of k units. Now, AF of x minus h plus k we have vertical stretch by factor A, followed by the horizontal and vertical shift in either order, but the vertical shift K units. So if you have a point on the graph, here's your point on the f of x function. Okay, then A is going to move move the point 8 times as far from the axis. Now if A happens to be negative, it could move it on the other side of the axis, but still 8 times as far. So let's just say, okay, here we have a point now on the graph of A f of x. Okay, what would the value of A be? Well, we're what, 1, 2, 3, 4, say about 4.5 times as far as we were from the x-axis, and on the other side. So I'm going to say that A in this case is approximately negative 4.5. 4.5 times as far, but on the other side. Then we do a shift of h units. Okay, well, let's just say, just for convenience, I don't want to go this way because I've written stuff there, so let's go this way. Maybe we can go one way as well as the other. Okay? So this is point on the graph of A f of x minus h, where h is some negative value. I have to put a scale on the graph. I can do 4.5 times as far, but I don't know how far that is. Whatever h is, that's how far it is. Of course, h is negative. And of course, then x minus h, if you had a number for h, minus a negative would be positive. But we should be familiar with that. Then we have a vertical shift. Okay? So we go up k units, and this point is on the graph of A f of x minus h plus k. Now we can depict this negative 4.5 by saying, okay, there's 1, 2, 3, 4. Yeah, it looks like maybe it's closer to 5 of these, but some of these might be too short. Let's say that one's negative 5. Now what I mean is, this arrow, all these arrows have the same length, presumably. These go in the opposite direction of this one. So these arrows move us 5 times as far from the axis, but in the opposite direction. Now, what if we had a whole graph and we wanted to do the same shifts and stretches? Okay, wanted to check the time. It's a royal pain if I go over 15 minutes in one of these things. Got to split the video. Okay, well, I'm going to do that, and I'm going to say, okay, let's say we've got a function here. Here's the graph of y equals f of x. Now actually, that probably wasn't a real good graph to use because some of these points are going to end up going off the board. And these points up here are going to end up way too far down here. But, okay, let's take this point on the graph and this point on the graph and this point on the graph, and maybe this low point here, we can probably get away with that. Okay, how are we gonna shift each point? Well, this point is this far from the axis in this direction. If A is -5, then if I want the point on the graph of AF of X, I'm going to have to go 5 of these in the opposite direction. So maybe I end up here. This is now a point on the graph of AF of X. Now, I shift H units, and H doesn't change. Okay, now the distance that I move can change. If I'm further from the axis, I've got to move further to get 5 times as far away. But H doesn't change. So H is going to bring me over the same distance it did here. And then K is going to bring me up the same distance it formerly did. Well, that's going to inconveniently put me up here, but that's where we're going to be. Now, if I do the same thing for this point, it's down just about as far as this one was, so maybe a little further, so maybe 5 of these bring us up to here. Now my labeling of H is inconvenient, I'll put that over here. So this is on the graph of AF of X. Then we move over H units and up K units, and